The GE AC6000, the most powerful diesel-electric locomotive in the world. The GE AC6000 combines the benefits of the proven technology of individually controlled AC traction motors housed in high-ad trucks, environmentally friendly air-cooled inverters, split cooling, electronic fuel injection, the capability of adapting to railroad management integrated control systems, and the new 6,000 horsepower 7HDL diesel engine. Let's take a look at some of the new features found on the 7HDL. There are now 2 turbochargers. These twin turbos, designed and built by GE, include all of the latest features, including backward curved compressor vanes for optimum efficiency. Fuel is delivered through an electronic fuel injection system, resulting in the highest fuel efficiency and the lowest emissions possible. The individual fuel pumps operate without push rods. This allows a stiffer system and decreased combustion variability from cylinder to cylinder. The intake manifold of the new engine is located in the V. This reduces the width of the engine and allows a cylinder head to be removed without disturbing the inlet manifold, increasing reliability and improving maintainability. While there are some components and features that are the same as the units with which you're already familiar, there is a lot like the 7HDL diesel engine that is different on these new locomotives. We'll be taking a look at what's new to help you, the engineer, become familiar with the AC6000. Before we start our walk-around, we want to remind you to always follow all railroad safety rules and regulations. The GE AC6000 is equipped with a 5,500-gallon fuel tank, with a new type of digital fuel monitoring system that can be seen on both sides of the fuel tank near the fuel fill, and on the video information display, the vid screen in the operator's cab. You may compare the level to the reading in the fuel sight glass. The fuel tank is integrated into the platform, eliminating fuel tank bolts. The drains for the lubricating oil and the water system are on the operator's side. As we work our way up the crew side of the AC6000, it's a good time for this additional safety reminder. Traction motor leads may have high voltage. The crew side digital fuel monitor should be compared to the fuel level sight glass. It should correspond to the reading on the digital fuel monitor on the operator's side. It is not a problem if the reading varies by a small amount. Engine stop switches are located on each side of the locomotive near the fuel tank. Pressing this button stops the fuel flow to the diesel engine. An important safety device is located in the doorway to the auxiliary compartment. This is a safety barrier bar. It does more than prevent access to the compartment. This bar must be in the horizontal position for the locomotive to operate properly. These LEDs are illuminated when the circuits are charged. A little further along the operator's side walkway, we come to the service areas for the lube oil and water. A green warning LED is conveniently located in the same compartment. With the control system powered, the LED illuminates when the water is called to return to the tank. Always make sure that the green LED is on before checking the water level in the sight glass. If the LED is not illuminated and the water sight glass indicates low water, remember that water is now being routed through the radiators. While the engine is idling, verify the level. Continuing down the operator's side walkway, we come to the handbrake. It must be fully released before moving the locomotive. The air compressor is near the back of the locomotive. It can be accessed from the crew side. If you need to add oil, the air compressor should be shut down. You isolate the compressor by turning off the LCCB, the local control circuit breaker located on the EC panel in the operator's cab. To avoid an oil spill, remove the fill only when the air compressor is not running. Oil should be near the top of the fill. A simple fill cap permits easy inspection. Now let's take a look at the operator's cab. The cab layout is similar to other wide cab layouts in the CSX fleet. Let's take a look at some of the new features. We'll start with the EC panel located behind the operator. Circuit breakers and switches are mounted on this pin. We'll take a look at these controls one at a time and talk about when they are used. The road crossing lights breaker and the radio circuit breaker are on the top row of the EC pin. On the second row, we find the flange lube, the display computer, and the long hood and short hood headlight breakers. The toilet tank heater breaker, the fuel tender control breaker, the fuel tank monitor breaker, and the air dryer and the air brake breakers make up the third row. The fourth and bottom row of breakers contains the running lights breaker, followed by the fuel pump breaker and the local control breaker. The next two breakers are the MTD multitask breaker that provides power to the low voltage power supplies, and the BCCB, the battery charge and computer toggle switch. This light indicates whether the computer has been turned on or off by the push buttons beneath the light. The EC engine control switch can be in one of four positions. The first position is jog, used by the mechanical forces to move the unit on battery alone. The second position is start. The EC switch must be in this position to activate the black engine start push button. If the switch isn't moved from start after the engine is started, the engine speed is limited to idle and power cannot be applied. The next position is isolate. When the engine is running with the EC switch in this position, the engine speed, as in the start position, is held to an idle, and power cannot be applied to the unit. In the isolate position, unlike the start position, an alarm bell sounds if the engine shuts down. When the engine is at idle and about to be operated, the EC switch should be moved to the run position. Run is the normal operating position for the engine control switch. An alarm bell sounds if the diesel engine is shut down with the EC switch in the run position. The MU headlight setup switch operates identically to the MU headlight setup switches on other road locomotives in CSX's fleet. To the right of the MU headlight setup switch is the engine start push button. Pressing this button begins the automatic starting process, including the pre-lube and priming of the AC6000's diesel engine. Directly below the engine start push button is the engine stop push button. Like the engine stop buttons on each side of the fuel tank, pressing this button stops the fuel flow to the diesel engine. Three lighting switches are next. They are the crosswalk light switch, the control compartment switch, and the front number light switch. The breakers for the engineers and helpers wall heaters are near the bottom of the EC panel. The last breaker on the EC panel is for the heater air conditioner unit. The front of the operator's cab looks similar to other wide-body cabs in the fleet, but again, there are some differences. The operator's console contains two video information displays, or VIDs. Each video information display has 2 rows of keys below its screen that directly correspond to the menu choices above. You may press the key that corresponds to the action you want to perform. The panel to the right of the video information displays contains the rear headlight switch, the front headlight switch, and the EOT emergency brake toggle switch that allows the operator to vent the brake pipe from the rear of the train. The engineer's strip heater control and the spotter circuit push button are located below. The electronic air brake console has the automatic brake handle on the left and the independent brake handle on the right. The master controller contains the reverser and the combined power handle. The combined power handle moves from idle to notch 8 and from idle through a gate to dynamic braking. While there is no difference in engine speed between notches 3 and 4 and between notches 5, 6, and 7, the computer-controlled propulsion system provides the appropriate increase in power delivered to the rails. The bell push button, the horn push button, and the alerter acknowledge push button are located in front of the console. The lower controls on the operator's console consist of circuit breakers for engine run, generator field, control, and dynamic brake. The gauge light switch, the heater air conditioner switch, and the step light switch are mounted below. The overhead console has a variety of devices, including an attendant call push button, the MU emergency shutdown push button or toggle switch, the engineer's desk light dimmer and switch, the radio, the audio alarm panel, and the crew member's desk light switch and dimmer. The crew member's console has a view-only video information display, an emergency brake valve, a radio module, a horn push button, and a strip heater control. Let's take a look at the GE AC6000's performance characteristics. The GE AC6000 has 6,000 horsepower available for traction. This is twice the horsepower of units in conventional road locomotive fleets. The tractive effort is 166,000 pounds. This is double the tractive effort of the same locomotives. There is an almost 80% increase in starting tractive effort. Dynamic braking has jumped from 60,000 pounds to 117,000 pounds. This performance, combined with higher mission reliability, offers an unbeatable combination of power and dependability that is important to CSX. Let's take a look at the step-by-step procedure involved in starting the GE AC6000. The combination of push-button in-the-cab starting and system information feedback on the vid screen makes the AC6000 the easiest starting locomotive ever produced. Let's review some of the basic steps that must be performed before starting any locomotive. Remember to follow all proper railroad safety rules and regulations. Proper inspection helps prevent operator injury as well as equipment damage. Verify that the crankcase is serviced with lubricating oil. Ensure that the cooling water is at the proper level by checking the sight glass. The air compressor oil level should be near the top of the fill. In the operator's cab, close the battery switch. Turn on the appropriate circuit breakers on the EC panel. The engine control switch should be in the start position. On the operator's console, turn on the appropriate breakers. Verify that the reverser is centered, that the throttle is in idle, and that the MU emergency shutdown switch is in the run position. Check the video information display on the operator's control console for any cranking restrictions. Notify all personnel near the locomotive that you are about to start the unit. The alarm bells ring in the engine cab as well as in the operator's cab. It may take up to 2 minutes before the engine starts to rotate. On a video information display, the engine crank screen automatically appears. The engine start in progress screen gives you the engine status during startup. After starting, re-inspect the diesel engine to make certain that there are no leaks and that all of the fluids are at the appropriate levels. Back in the operator's cab, configure the EC panel breakers for the direction the unit will be moving. The EC engine control switch should be moved from start to run. In the event that the engine does not start, you have troubleshooting assistance from the VID's locomotive monitor screen. Select Locomotive Monitor from a video information display. From the locomotive monitor, select Engine Cranking. This screen displays cranking operational parameters. 2 readings on the top graph depict the actual speed of the diesel engine and speed equivalent cranker. Lube oil pressure and fuel pressure are displayed at the top right area of the screen. The left column in the center of the screen depicts the contactor's commands and transfer switch status. The center column gives switch and relay status. The right column displays other information related to engine control. The automatic starting process is just one of many computer-controlled operations on the AC6000. Now we'll take an in-depth look at the video information displays on the GE AC6000 locomotive. The front of the operator's cab looks similar to other wide-body cabs in the fleet. But again, there are some differences. The operator's console contains 2 video information displays, or VIDs. Each display has 2 rows of keys directly below its screen. The top keys are yellow. The keys on the bottom rows are off-white. Pressing the menu key on the top left-hand corner of the key rows displays the AC6000 menu screen. Press F1, the home key, to return the display to the main operating screen. Pressing the menu key twice on any screen brings up the gauge screen. The F1 through F8 keys correspond to the top row of choices on the screen menu. The 1 through 8 keys select the bottom row menu choices that are determined by the action being performed. The 0 through 9 keys are also used to input numbers. The display on the cruise console is the auxiliary display. On power-up, the cruise screen is similar to the operator's right display. The crew display is a look-only screen. Gauges and locomotive condition reports can be noted, but no changes to the locomotive setup can be made. The right display screen on the operator's console is called the engineer's right display. It powers up with operating gauges. This screen contains information that the engineer needs to know when operating the locomotive. This screen may be viewed on any of the displays in the cab. The left display on the operator's console is referred to as the engineer's left display. It powers up as the MMI, man-machine interface. In most cases, no gauges appear on this display. Loco Monitor F8 can be accessed by this display and by the crew display, but not by the default engineer's right display. As we've said, the right screen on the operator's console powers up, that is, defaults to the operating display, and the screen on the left defaults to the man-machine interface display, the MMI. The operator may choose to switch the location of the displays. and have the operating display on the left and the MMI display on the right. In the rare instance of a screen malfunction, it's the operator's responsibility to switch the remaining display to the operating display. Pressing any display's menu key twice always causes the gauges to appear. This arrangement allows the engineer to have the additional screen displaying support information as an MMI display, while also allowing that screen to be a true backup to the operating display in the event of a problem. We'll take a closer look at the screens, starting with the operating display. The operating display is the top level, or first screen. Air brake information is located in the top left-hand corner of the display. When the air brake system loses communication with the control system, all of these boxes contain asterisks and a penalty brake application will occur. ER stands for equalizing reservoir pressure. The BP indicates brake pipe pressure. Equalizing reservoir information and brake pipe pressure information are also available in bar graphs immediately to the right of the digital readings. The blue pointers indicate the regulating valve setting, also known as the feed valve setting. Rear represents the brake pipe train line pressure information received from the end of train EOT device. If a reading of less than 45 psi is received, the box turns red and the audio alarm panel beeps 6 times. If the EOT is off, or if communication between the EOT and the locomotive is lost for an extended period, the reading will be 3 asterisks. The next status marker, or box, is labeled flow. Like the other areas in the air brake section of the display, a loss of communication results in this box displaying 3 asterisks. However, unlike the other areas, the readings in the flow box refer to the cubic feet per minute flowing to the brake pipe, rather than pounds per square inch of pressure. BC stands for brake cylinder pressure. Main is main reservoir pressure. If the main reservoir pressure falls to within 15 psi of the equalizing reservoir setting, the box turns red. The speed indicator occupies the center of the top of the display. The analog segment has a scale of 0 to 80 miles per hour. The digital reading also indicates locomotive speed in miles per hour. This display has 3 ranges. Low scale from 0 to 4.99 miles per hour in increments of 0.01 miles per hour. Medium scale from 5 to 9.9 miles per hour in 1/10 mile per hour steps, and high scale above 10 miles per hour in 1 mile per hour segments when accelerating and decelerating. When traveling above 5 miles per hour, an accelerometer appears adjacent to the digital readout. This indicator is green when you are accelerating and yellow when you are decelerating. The distance box is to the right of the speed indicator. Enter the desired number from the distance setup screen. The next box contains the railroad name and road number. The tractive effort bar graph indicates the average tractive effort in green from 0 to 180 kilopounds, and the average braking effort in yellow from 0 to 120 kilopounds. The effort kilopounds box is located immediately below the center of the tractive effort bar graph. This provides the engineer with a digital readout of the bar graph information. With the same range as the bar above, tractive effort when motoring is displayed numerically in green, and braking, when in dynamic braking, is displayed in yellow. The reverser position box is to the left of the tractive effort bar graph. It indicates whether the reverser handle is moved to forward, centered, or to reverse. When in trail, the reverser handle should be removed. It should be noted that whenever the handle is moved to forward or reverse, the independent is automatically cut into lead. This is a safety feature ensuring independent brake control is available when the reverser is moved. The throttle box is on the other side of the effort kilopounds readout. It displays in green the position of the combined power handle from idle to notch 1 through notch 8 in motoring, and in yellow from setup to B1 through B8 in braking. As we move down the operating display, we come to the indicating lights or alarm lights. Starting at the left, we find the wheel slip light. This indicator gives the engineer information through the train line that the wheels on one or more of the locomotives in the consist are slipping or sliding. PCS open lights when an emergency or penalty air brake application has occurred with the unit's power limited to idle. Dynamic braking will continue to function after an emergency or penalty application of the air brakes. Sand comes on when the unit is applying sand. It lights during manual and automatic sanding. Brake warn flashes yellow to tell the engineer that a locomotive in the consist is encountering excessive dynamic braking current. If this condition occurs, you must use the combined power handle to reduce the dynamic braking demand of that locomotive. Dynamic braking is reduced in the entire consist. The alerter displays a countdown to penalty brake application. The MU alarm indicates a train line alarm. The EOT system marker displays EOT BAT W on a yellow background when the EOT battery is weak. The display changes to EOT BAT D when the battery is dead. EOT valve appears if there is a failure in the EOT emergency valve circuit. If communication is lost between the locomotive and the EOT device, EOT FR COM and EOT RF COM indicate the direction of COM loss. The rear box in the air brake information area will display 3 asterisks. EOT motion on the end of the marker light row indicates if the EOT is stopped or moving. On the left-hand side of the screen, beneath the marker lights, we come to the air brake message window. This area is not visible until it is needed. It's important to follow the instructions listed to recover from an undesired brake application. Directly below is the EOT status area. The top line in the area is labeled marker. On indicates that the EOT marker light is blinking. When the display changes to off, it is an indication that the marker light is not blinking. The lower line in the EOT status section is labeled EM. EM stands for emergency. This readout tells the engineer the two-way EOT status. It may read enabled, disabled, or in the case of extended communication loss, 3 asterisks. The automatic brake box reports whether the automatic brake is cut in or cut out. The independent brake box indicates whether the independent brake is set for lead cut in or trail cut out. The fuel status area uses a bar graph and a digital readout to tell the engineer how much fuel remains in the fuel tank. When the level drops below 550 gallons, both indicators turn yellow. Remember, when the fuel level falls below 1,000 gallons, you must notify the train dispatcher that the unit is low on fuel. The operator message window, where summary messages and reports appear, replaces the DID panel. That completes our look at the main operating vid screen. Now let's go through the air brake setup procedure. Note, before setting up the air brakes, remember that the locomotive must be stopped. The reverser must be removed, and the generator field breaker must be off. This, like most other setups, is performed from the top screen of the operating display. Let's press Air Brake Setup, the 1 key. To change the air brake setup, you must press Change Setup F3. The top information line beneath the screen title displays the current air brake setup. The line designated as Desired Settings updates as you make your changes. F1 and F2 change the feed valve setting. When the unit is set for lead operation, pressing F4 toggles the automatic brake between cut in and cut out. F6 toggles the independent brake between lead and trail operation. To save your new setup, press F7, Save Setup. Remember, before saving, review your desired settings. If you choose to leave the air brake setup screen without saving your changes, pressing F8, Cancel, returns you to the previous electronic air brake setup screen. Caution: if consist starts to move, place the reverser in the direction of travel to cut in the independent brake. Now that we've seen how the basic changes are made to the air brake setup, let's go step by step through the procedure to change ends. To operate the locomotive in the lead position, you should set all of the other locomotives in the trail position. Place the independent brake handle in the full application position. Place the automatic brake handle in the release position. From the air brake setup screen, press F3. Press F6, Lead. Use the F1 and F2 keys to adjust the pressure for the equalizing reservoir. When the equalizing reservoir is at the required pressure, press F4 to cut in the automatic brake. Press F7 to save the setup. The locomotive is set for lead operation. Press F8 to return to the main menu on the operating display. Now let's set up the unit for trail operation. Make sure that the combined power handle is in idle. The reverser is removed, and that the engine run, generator field, and control breakers are off. Fully apply the independent brake. Make a full service brake pipe reduction. After the equalizing reservoir and the brake pipe have stopped exhausting, go to the air brake setup screen and press F6, Trail. Then press F7 to save the new setup. The independent brake and the automatic brake are now cut out. Press F8 to return to the main menu on the operating display. To complete the setup, move the automatic brake handle to the handle off position and set the appropriate switches for trail operation. This procedure covers setting up the EOT device. From the operating display, press 2 on the bottom row of keys. You are looking at the end of train setup. Press Modify ID, F3, to enter the end of train device number. Using the number keys on the bottom row, enter the 5-digit ID number. If you accidentally enter an incorrect number, backspace to delete the entry and enter the correct number. Press F7 to save the ID number. F6 tests the communications link with the EOT. When the rear end device's test button is pressed, Arm Now appears. You should immediately press Arm F7 to arm the device. Pressing the rear end device's test button also starts the test sequence. The software revision, battery status, and brake pipe pressure will be displayed. When the system is armed, the operator can vent the brake pipe from the rear of the train by moving the EOT emergency toggle switch on the console to the open position. Entering and saving all zeros as the EOT number or pressing F7 disarms the EOT. F8, exit, returns you to the top operating display screen. Each display's distance counter is set up from the main menu by pressing the 4 key. The display changes, and F4 allows you to set a specific length. Use the bottom row of keys to enter the desired number. If you make a mistake, use F4 backspace to erase the last digit. F6 toggles between count up and count down. F7 Save Preset saves the new length and returns you to the top distance counter setup screen. To leave this area without saving any changes, press Cancel F8 to return to the top distance counter screen. When you have entered and saved the proper distance, F4 on the main operating display begins counting in feet the distance traveled. When the distance counter preset is set at 0 and count up is selected, the distance counter counts up from 0. Press F8, exit, to return to the main operating screen, from which pressing F4, distance start, starts the countdown, or count up of the distance counter. To access speed control and power reduction features, you must press 5 from the main menu of the operating display. 2 additional menu choices appear. They are slow speed and power reduction. Slow speed allows you to set the slow speed control. Power reduction provides access to the manual power reduction mode. We'll begin with a look at how to set the slow speed control. The 5 key changes the display to the slow speed control screen, from which you can toggle the slow speed and plug mode off and on. Raise and lower the target speed by pressing and holding the keys, and make the current speed the target speed. Pressing the 4 key, Enter New Target, allows you to set the target speed. Use the bottom row of keys to enter the desired speed. 2 keys on the top row may be used when needed. They are the decimal point key and the backspace key. F7 Save Target saves the new target speed. Pressing F8 returns you to the previous screen without saving any changes. This time we'll select Power Reduction from the speed control screen. The manual power reduction options are now available. F1 toggles the reduction on and off. F3 changes between MU and lead-only operation. Use the F5 and F6 keys to raise and lower the combined power handle load response, referred to on the display as notch power percentage. You may hold these keys or repeatedly press them to adjust the percentage. In this mode, the operator has control of the load. Press F8 to exit. Like most of the setup areas, the screen controls display is accessed from the main menu by pressing the 7 key. Use the F2 and F3 keys to choose the location where the gauges will be displayed. F6 and F7 change the brightness level of the screen. Let's take a look at some of the menu selections on the top row. These are accessed through the top row of keys. Lead sand, which is always available, provides sand to the lead axle depending on the direction the unit is traveling. Trainline sand, which is available below 12 miles per hour, sends a request for sand from all of the locomotives in the consist. The following applies to either sand button. Each press gives you 30 seconds of sanding. You have a maximum of 3 sequential presses while moving. When you are not moving, each press gives you 10 seconds of sanding. That minimizes sand usage around terminals. In emergency, while moving, you have 60 seconds of sanding. Even with all of your sanding options, it is always better to allow the system to determine when to apply sand. Let's take a look at where another important menu selection takes you. From the main operating display, F5, Switches, accesses the Switches screen. The menu choices change, and the F1 and F2 keys control the on-screen switches. The dynamic brake cutout switch cuts out dynamic braking on this locomotive. When in lead, train line signals will continue to be sent to other units in the consist. The locked axle cutout switch cuts out the locked axle alarm. Wheel slip protection is still active. Motor cutouts, F7, changes the display to the motor and speed sensor cutouts. From the top, the display includes the motor number, the motor and speed sensor cutout switches, the motor status lights, and the motor cutout switches. Pressing a key in the top row, for example F1, SSCO1 cutout, will cut out the number 1 traction motor and its speed sensor. The display changes as the top toggle switch in the motor and speed sensor cutout row moves down, and the number 1 traction motor's status light goes out. Pressing the 2 key, TMCO2, cuts out the number 2 traction motor. This time, the toggle for the affected traction motor moves to cut out in the motor cutout row. As before, the traction motor's status light goes out. In either case, the traction motor will not be powered. Warning: when the speed sensor is cut out, locked axle alarm protection is no longer available for that motor. Most of the setup areas may be accessed from the main menu on the locomotive operating display. We're going to examine an area that can only be accessed through an MMI display, typically the engineer's left display or the crew member's display. Pressing F8, Loco Monitor from the main MMI or crew member's display, or F2 from any monitor screen, brings up the locomotive monitor display. Starting at the top left of the screen, there are graphically displayed gauges of water temperature, lube oil temperature, alternator volts, alternator amps, and field amps. Additional information is available in the center of the screen. Of particular interest to the operator is this box located to the right. Here, GE's individual axle control allows you to monitor each axle for speed and load. On this display, as on all of the monitor screens, the F1 key freezes the display to make it easier to read a value that may be fluctuating. Pressing F1 again resumes the normal screen update function. When finished viewing the monitor screens, simply select Exit F8. The GE AC6000 will always be the leader, with tomorrow's technology today, and the ability to incorporate the technology of the future tomorrow.